So let us take a few more questions and answers in operating systems. So what is a thread? Thread is a lightweight process, as we generally know it. Thread. So it has something of its own, but most of the things are shared with the process. So a thread, also called as lightweight process, is a basic unit of CPU utilization. Well, the process is also a basic utilized, but because process you can have many threads which can be generated from a process. So this is the basic unit of CPU utilization, and thread comprises of, or it is identified as the thread ID, the program counter, the register set, and a stack, register set, program counter, and thread ID. So it shares with other threads belonging to the same process its code section. So thread share its various thread share their code section, the data section, and the operating system resources such as open files and signals. Next is what are the benefits of multi-threaded programming? Benefits of multi-threaded programming. There are various benefits of multi-threaded programming. Multi-threaded means many threads. If the system or the process is able to create threads, and the system is, or the CPU is able to run the thread, then multi-threaded programming is being called. So the benefits of multi-threaded programming can be broken into 4 major categories. First is the responsiveness will be very fast. The resource sharing, because there are various resources and they can be shared. The economy also. And the most important is the utilization of multi-processor, more than one processor architectures. That only can be employed when you use this multi-threading. Now we have to compare user threads and kernel threads and define thread cancellation and thread target. So first of all, before we will talk about this, all of this. So first we'll see the thread cancellation. So the thread cancellation is the task of terminating a thread before it has completed. Cancellation means termination before it is completed. So a thread that is to be cancelled is often referred to as the thread or target thread. For instance, if multiple threads are concurrently searching through a database and one thread returns the result, the remaining threads might be cancelled. Okay, this is the target thread. Now we come to this one, user thread and kernel thread. So user thread, kernel thread. User thread is what? User threads are supported above the kernel and are implemented by a thread library at the user level, while the kernel threads are supported directly by the operating system. See, there's a difference. Kernel threads are supported directly by operating system. User thread are supported above the kernel and are implemented by a thread library at user level, while the kernel thread is supported directly by the operating system. Thread creation and scheduling are done in the user space without kernel intervention. Therefore, they are fast to create and manage. So thread creation, scheduling, and management are done by the operating system. Therefore, they are slower to create and manage compared to user threads. This we are talking about the kernel thread. Then blocking system call will cause the entire process to block. And if the thread performs a blocking system call, the kernel can schedule another thread in the application for execution. So these are the certain differences also from with respect to this kernel and user thread. What are the different ways in which a thread can be cancelled? How can you cancel a thread? So, see, cancellation of target thread may occur in various scenarios. First is your asynchronous cancellation. The other is your deferred cancellation. What is asynchronous cancellation? One thread immediately terminates the target thread. This is called as asynchronous cancellation. While deferred cancellation means the target thread can periodically check if it should terminate, allowing the target thread an opportunity to terminate itself in an orderly fashion rather than abrupt termination or asynchronous cancellation. Define the CPU scheduling. There are various threads. So what happens that if you are booking a ticket and you have just opened it for one day, so many people will come. Now you have to schedule them. Okay, kids time this, female time this, and men time this. So the CPU has to schedule for proper resource utilization, proper management of the resources and the other aspect of relating to the system. So CPU scheduling is the process of switching the CPU among various processes. So CPU scheduling is the basis of the multi-program operating system. By switching the CPU among different processes, the operating system can make the computer more productive. Means it will use all the resources, like the CPU should not sit idle. The resources have to be utilized to be maximum. The responsiveness has to be very fast. This user need to understand that my system is very fast, very efficient, and all those benefits which CPU scheduling gives us. Next is what is preemptive and non-preemptive scheduling. Say in layman words, preemptive and non-preemptive means preemptive that can be stopped. Non-preemptive means that cannot be stopped. This is a layman language. Now let us see what exactly it means in terms of operating system. Under non-preemptive scheduling, once the CPU has been allocated a process. See, in non-preemptive scheduling, once CPU has been allocated to a process, the process keeps the CPU until it releases the CPU either by terminating, first by terminating itself, or switching to the waiting state. Okay, so if it has to wait for some input output happening, so it will wait, or it will terminate, or it will end. But preemptive scheduling, in this type of scheduling, it can preempt a process which is utilizing the CPU in between its execution, and give the CPU to another process. So there are various scheduling, like round robin is there, and shortest job first. All those scheduling are there, and in this some are preemptive, some are non-preemptive. What is a dispatcher? See, you have a mail. You have written a mail. Now you have put it inside an envelope. Now you ask the dispatching person to please dispatch it, and this is the dispatcher. This is in layman language. But in operating system terms, things have come from real life only. So dispatcher is the module that gives control of the CPU to the process selected by the short-term scheduler. So you have short-term scheduler. Short-term scheduler has selected now this process is going to be given to the CPU for execution. So the dispatcher gives control of the CPU which is selected by the short-term scheduler, which is selected by the, of course, STS. So this there is a whole process. First of all, there has to be a context switch, means some process is there, now the other process is going to come. So the process transition, that is the saving of various things, has to be done. Then switching to the user mode, and then jumping to the proper location into the user program to restart the program. So you have to save where to return, because you have stopped or you have allowed a process to wait so that other process can be given to the CPU, so that previous process or information has to be stored. What is dispatch latency? Dispatch latency. Now, dispatcher does what? It gives the control of CPU to a certain process. Now, the time it takes, that is the time taken by this dispatcher to stop one process and then start another process or start another running, is known as the dispatch latency. So this is the time. So this is the time and overhead which needs to be minimized. Next is, what are the various scheduling criteria for CPU scheduling? What are the various scheduling criteria for CPU scheduling? So there are various criteria. First is your CPU utilization. This is the criteria. Throughput and turnaround time, the waiting time, the response time, and all these are, they are combined. They have a combined effect of saying that whether the CPU is scheduled properly, CPU is working properly, or the process has been synchronized properly, given properly. So all these things makes your CPU and your scheduling and operating system with respect to the hardware efficient. Define throughput. See, throughput means in a normal term, if you have a production house, okay, production firm, now it produces 10 material or 10 object in 1 minute. Now one machine has come, now it is able to produce 100 object in 1 second. So this is the throughput. This is the output or throughput. So the throughput in CPU scheduling is the number of processes that are completed per unit time. Number of processes that are completed per unit time. If you have a long processes, this rate may be 1 process per hour. For short processes, this can even go to the minimum possible, 10 processes per second, and like that. Per nanosecond also, millisecond also it can go. What is turnaround time? Turnaround time? See, your friend is walking in front of you. He is not aware you are walking just behind him. So what you are going to say, hello Mr. X. That friend is going to listen and he will turn back and he will respond to you, right? So the turnaround time is the interval from the time of submission to the time of completion of a process. You submit a process and the time which is taken in between to complete, the time of completion of the process. So it is the sum of period which are spent waiting to get into memory, waiting in the ready queue, executing on the CPU, and doing input output. All this corresponds to or adds up to your turnaround time. Define the race condition. Race condition means now your school has organized a play day. Okay, now your friends or some of your athletes are running, and you are trying to win. Everyone wants to win, so they are racing, and one would win, and some may not win. So this is what in layman terms we can understand. So when several processes access and manipulate same data concurrently, then the outcome of the execution depends on a particular order in which the accesses takes place. Okay, this is called the race condition. So we want to avoid this race condition. Only one process at a time can manipulate the shared variable. We don't want to allow these processes to access and manipulate the same data concurrently. So this is the race condition. What is a critical section problem? Critical section problem is that you have a bathroom. Okay, you have a single bathroom. There are 10. Your friends are 10. You have 10 friends. They have come for some exam. Now everyone cannot use bathroom at the same time. Say everyone cannot use the bathroom at the same time. So that bathroom is a critical section. Just trying to make you understand. So consider a system consists of n processes. Each process has a segment of code called a critical section. Every process has a segment of code called the critical section, so in which the process may be changing common variables, updating a table, writing a file. So when process is executing in its critical section, no other process can be allowed executing in its critical section. This is the critical section problem. Next, what are the requirements that a solution to the critical section problem must satisfy? Now there is one bathroom, there are 10 people. Now how they are going to take bath and get prepared for some exam? So there are three requirements. First is your mutual exclusion, progress, and bounded waiting. These are the three requirements. Define entry section and exit section. Entry section and exit section. See, in a critical section problem, which we just understood, the critical section problem is to design a protocol that the processes can use to cooperate. So each processes must request permission to enter its critical section. Each processes must request the permission to enter its critical section. You cannot enter a bathroom when your friend is already there. So the section of the code implementing this request is the entry section. And the critical section is followed by an entry section. The remaining code is a remainder section. So whenever your friend would come out of the bathroom, he will broadcast, or he will tell you, if you are number second or next in line, he will ask for you to control or to go to that critical section. Give two hardware instructions and their definitions, which can be used for implementing mutual exclusion. See, we have a test and set. This is a test and set, which is a Boolean value passing, and this is a target. So we are assigning target to RV, and we are saying true to target, and then we are just returning TV. So when we are just assigning true to target here. Then we have a swap. What swap is doing? Swap is swapping or exchanging the value of A and B. So this is how these are the two hardware instructions: test and set and swap. These are definitions also, which can be used for implementing the mutual exclusion: test and set and swap. What is semaphore? Semaphore. See, first is you have different processes. Now this process needs to be synchronized. So semaphore is for synchronization. Semaphore is a synchronization tool. So semaphore S is a synchronization tool, which is an integer value. It is an integer value that, apart from initialization, is accessed only by two standard atomic operation, wait and signal. It is an integer value that can only be accessed by two atomic operation, wait and signal. So semaphores can be used to deal with n process critical section problem. It can also be used to solve various synchronization issues problems in the operating system. For example, this wait, see how it is working. The classical definition of wait is wait, and we, while s equal to less than equal to 0, we do s minus minus. Otherwise, for signal we add 1 to s. So for waiting we decrement s, for signaling we increment s. Next question is define busy waiting and spinlock. Busy waiting and spinlock. See, when a process is in its critical section, changing its value or updating, any other process that tries to enter its critical section, means this process critical section must loop continuously in the entry code. Must, because it is not waiting, means it is not able to enter. So this is called busy waiting. Now this process wants to enter here. This is already working, so this has to wait. So this is busy waiting, and this type of semaphore is called a spin lock, because the process while waiting for the lock, it is busy waiting. So this type of semaphore is at this point is known as spin lock. How can we say that first come first serve FCFS scheduling algorithm is non-preemptive? As I suggested in the previous question also, there are certain scheduling which are preemptive, which are non-preemptive. So first come first serve is non-preemptive. Non-preemptive means the first which has come, the process will be honored first. So it will take all the CPU time, CPU burst, and then it will complete, and then the next which has come will be given the chance to work on or to execute on the processor. This is non-preemptive. So once the CPU has been allocated to the process keeps the CPU until it releases, either by terminating or by requesting some input output. So we can say that the first come first served scheduling algorithm is non-preemptive. What is waiting time in CPU scheduling? See, the process, if it is waiting, then it is waiting. You are waiting outside the bathroom to go inside, so you have waiting time. So in this OS terms, waiting is the sum of periods spent waiting in the ready queue. The time which is at the ready queue. Now you know that you are about to enter the the house or a room. So CPU scheduling algorithm affects only the amount of time that a process spends waiting in the ready queue. What is response time in CPU scheduling? I gave you an example of your friend who is working in front of you. So what response he gives? So response time is the measure of the time from the submission of a request until the first response is produced. You are asking him, and he will your voice or the sound you create will reach his ear, and he will turn because he will turn and he will recognize you. He will take time to recognize you also. But the first time he will turn back, that is the response time. So response time is the amount of time it takes to start responding, but not the time that it takes to output that response. That means he has not come back, he has not shook hand with you. So at this time, when he just heard and he turned back, this is the response time. Now differentiate long-term scheduler and short-term scheduler, LTS and STS. See, long-term scheduler or a job scheduler. See, long-term scheduler is also known as a job scheduler. Short-term scheduler is also known as a CPU scheduler. So long-term scheduler or job scheduler, it selects a process from the job pool and loads it into the memory for execution. For short-term to actually work on it. While the short-term scheduler or a CPU scheduler select the process among various processes that are ready to be executed, and they are ready to find that they are expressing their will to go into the processor. So it allocates the CPU to one of them. Write some classical problems of synchronization. Bounded buffer problem, reader-writer problem, dining buffer problem. Okay, these are classical problems of synchronization. Next is when the error will occur when we use the semaphore, when it is going to create some error. See, when the process interchanges the order in which the wait and signal operations on the semaphore mutex. So when a process replaces a signal with a wait, and when a process omits the wait or the signal, these are the conditions where the semaphore is giving to give you an error. Now, what is mutual exclusion? Mutual exclusion means when I am speaking, you are not going to speak. When you are speaking, I will not speak. Mutual exclusion means a way of making sure that if one process is using a shared modifiable data, the other process will be excluded from doing the same thing. So each process executing the shared data variables exclude all others from doing so simultaneously. This is called the mutual exclusion. Define the term critical regions, the regions which are very critical. What are these regions? So critical regions are small and infrequent, so that the system throughput is largely affected by their existence. Critical region is a control structure for implementing mutual exclusion over a shared variable. Let me tell you again. Critical region is a control structure for implementing mutual exclusion. This one, mutual exclusion over a shared variable. What are the drawbacks of monitors? Monitor concept is its lack of implementation. Most commonly used programming languages. These are the drawback of monitors. And there is a possibility of deadlocks in the case of nested monitor calls. So these are the drawbacks of monitors. What are the two levels in thread? Two levels. Say there are two levels of thread. One is the user level and the other is kernel. So these were few more questions in operating system. We'll be covering more in later session. Thank you so much.